The given topic is polar representation of a complex number. Before we start, let us quickly see what a polar coordinate system is. Cartesian coordinate system has two coordinates, x coordinate and y coordinate. We call it x-axis and y-axis as well. And then there is a point of origin. This is the point where these two axes intersect. And any point in this coordinate system, let's say P, has two numbers, x and y. These numbers are the ordered pair numbers. That simply means the order of these numbers are very important. The first number represents the point or the projection on x-axis, and the second number represents the projection on the y-axis. So first number x represents any value on the x-axis, and the second number y represents any value on the y-axis. And as you have seen in the Argand diagram, the y-axis is considered the imaginary axis and the x-axis is considered as the real axis. So a number such as z is equal to x plus iy can be represented by the point P, where x is the real part and y is the imaginary part. Now the same complex number x plus iy can be represented in a different coordinate system, which is called the polar coordinate system. The polar coordinate system is also a two-dimensional coordinate system, just like the Cartesian coordinate system. The point O, the origin, here is called the pole. So the fixed point 0 is called the pole. That's why polar coordinate system. And we have only one axis. This is called the polar axis. Now this polar axis is usually the positive x-axis. Any point in this system, let's say P is a point in this system, are given by, again, ordered pair in which the first part is called r and then a theta. R is called the radial coordinate, and theta, this is r, and theta is called the angular coordinate. Now radial coordinate is nothing but the distance from the pole to the given point. So r is nothing but the distance OP, and theta is the angle that OP makes with the polar axis or the positive x-axis. As we have seen in polar coordinate system, we write a point as r theta. But the same point can be written as P xy in Cartesian coordinate system. And using the help of Argand diagram, we can represent a complex number, say x plus iy, in Cartesian coordinate system. Now, if we try to infuse both the coordinate systems together, what do we see? That we have two axes, say y-axis, and this becomes our x-axis. And then the very point P xy has projections on x-axis as x and projections on y-axis as y. But we know that OP is equal to r. So our r is equal to under root x square plus y square. Or the complex number z is equal to under root x square plus y square. If you have some understanding of trigonometry, then you simply know that the length x is equal to r cos theta and y is equal to r sin theta. That is, projection of OP on x-axis is r cos theta and projection of OP on y-axis is r sin theta. The value of this length is r cos theta and the value of this length is r sin theta, and also this length is equal here as well, so this is also r sin theta. And if we consider the triangle, this is the right angle triangle, we have theta as one of the angles. So if in polar coordinate a point is given by r and theta, that simply means it is r cos theta and r sin theta in Cartesian coordinate system, and that is our xy. So if r and theta is given, and if you have to find the value of x and y, then you simply write x is equal to r multiplied by cos theta, and if you find the value of y, you will write r multiplied by sin theta. And if you are given the x and y values, then you can find r by using the formula r is equal to under root x square plus y square. Finally, given a complex number, we can write it as z is equal to r cos theta plus I sin theta. Here r is actually mod z, the distance from pole to the given point, and theta is called the argument of complex number, and this whole setup is called the polar form of z. So we can represent a complex number in the polar form by writing the radial part r multiplied by cos theta plus I sin theta. If you want to become more mathematical, so we can say that polar coordinates are something like r theta, where r is obviously greater than or equal to 0 because r is the distance, and theta lies between pi and minus pi. Let us take one example. So the complex number is given by z is equal to under root 3 plus iota, and we have to represent this complex number in polar form. For that, first of all, we have to find mod z, that is the radial part of the complex number r, and we have to find theta, the angle it makes with the polar axis. First, let us see z is equal to under root 3 plus iota once again. Here, the real part of z, or the real z, is under root 3, and the imaginary part of the complex number is 1. Now, mod z, that is the distance r, is equal to under root real z square plus imaginary z square. This is the formula to find r. So it will be under root 3 square plus 1 square, that is under root 3 plus 1 under root 4, and it is equal to plus minus 2. But since r is a mod of z, we will take only the positive value, and the value is 2. So r is equal to 2. To find theta, we will simply use the tan inverse of y-axis by x-axis. Here the y-axis is the imaginary part, so 1 is the imaginary part by the real part, and real part is under root 3. So our theta is tan inverse under root 1 by tan inverse 1 by under root 3. And this complex number z is equal to under root 3 plus iota can be shown in the polar form as 2, the distance, comma, the angle theta, and here theta is tan inverse 1 by root 3, and this is how we can show it. And I am giving you homework, only 2 questions. The first one is represent the conjugate of under root 3 plus iota in the polar form, and the second one is if mod z is equal to 2 and argument of z is equal to pi by 3, argument of z is actually the angle theta, then obtain the algebraic representation of the complex number.